Hello everyone and welcome to the Speculative Wildlife Research Center, where we reimagine creatures and monsters from all realms of fiction through the lens of speculative biology. Today we will have a video unlike the usual for our channel. We will be returning to our world of dragons, but not to take a look at a new clade or species, but rather at a particular adaptation of the dragons we have yet to meet: flight. Ahead of next week's video, we will be seeing how the two remaining superorders have managed to rise to the skies before we see the specifics of these types of dragons. As such, we will be drawing not a dragon per se, but rather a few diagrams to show how the flight of these dragons developed, in preparation for the rest of the videos in our world of dragons. If you've been enjoying this series, please consider supporting the channel by liking and subscribing, donating on Ko-fi, or joining our Patreon. Links available in the video's description. Now, without further ado, let's get started. While other members of their kind took to dominating the land and the seas, some dragons were much more ambitious, finding a way to rule over the skies instead. This process, however, was not easily achieved. While modern flying dragons come in all shapes and sizes, they all come from a single ancestor that was as different to them as they are now to one another. The early ancestors of flying dragons were small, tree-dwelling creatures that diverged from primitive drakes. Their limbs were long and strong, adapted for moving along the branches, hunting small animals and escaping the attention of larger terrestrial predators. However, tree-dwelling animals could be hard to catch, especially as birds began radiating and dominating this environment. Flying prey were harder to catch than lizards and bugs, and these dragons would have to adapt in order to keep developing as predators. This adaptation was twofold, beginning with the development of a thin skin membrane that extended between the anterior and posterior limbs, the arms and legs of these creatures. As with many creatures in our world, including draco lizards and many mammals, this membrane helped these ancestral dragons leap and glide between the treetops. However, this adaptation was helped by a second, much less visible structure that grew on the inside of these creatures. The digestive system of these dragons developed a large sac, inside which gaseous byproducts of digestion, including small amounts of methane, were stored. These sacs helped reduce the weight of these creatures in a manner similar to the hollow bones of birds, thus improving their mobility as they glided. This added capacity for horizontal movement allowed the ancestral flying dragons to not only catch prey in the air, but also gave them a chance to expand, to reach new spaces and environments without having to touch the ground. As these creatures expanded and diversified, one particular population developed an adaptation that would help them outcompete all others of their kind. These dragons developed a symbiotic relationship with specialized bacteria, modernly named Methanobacterium. These bacteria live in the digestive system of these dragons, and of all their modern descendants, where they help process the meat ingested by the dragon. Similar bacteria were already common to the clade, as by helping in digestion they allowed a general reduction of the digestive system, which made the ancestral flying dragons lighter and allowed more space for their flotation sac to develop. However, what makes Methanobacteria special, as their name may suggest, is the heavily increased production of methane as a secondary output. This methane slowly accumulated in the sac of these dragons, and, being much lighter than air, helped them leave mere gliding behind and attain real flight. As these dragons became lighter, their gliding membranes evolved into more complex structures, and so the first flying dragons started quickly migrating and diversifying into the rest of the world, reaching places untouched by most other kinds of dragon, such as the Americas. Nowadays, flying dragons can be found all across Europe, Asia, and North and South America, and have diverged into two very different superorders, those that we will focus on as we go forward in our exploration of this world of dragons: clade Dracomorpha and clade Celoserpens. And that's it for our speculative biology look into the flight of dragons. This was a new kind of video for our channel, focusing on the biological adaptations of a creature rather than on the creature itself, up to and including the drawing we made for it. I did this because next week we will be seeing a type of dragon lots of people have requested to see, and doing this video beforehand allowed me to improve that script by not making it too cluttered or complex, removing information that, while relevant to these dragons, was not specific to them. Of course, flying dragons would need two different things to be truly able to fly: managing to lose enough weight to gain lift, and attaining structures to maintain said lift and navigate in the air. The first of the two was easily developed as a result of normal digestive processes, using methane to make these dragons light enough to fly. Methane, of course, might seem a little bit cliché in dragon speculative biology, but the truth is it fits perfectly for this purpose. It is lighter than air, it is produced by biological organisms, and, as we will see in the future, it is even flammable. The second adaptation, the patagia or skin membrane of these dragons, was quite fun to think about. Many gliding reptiles and mammals in our own world have developed the type of membranes that could, with enough time and environmental pressure, develop into the wings of creatures such as bats or pterosaurs, giving us a good deal of reference to work with. Such a mechanism has already been explored in the channel through the jaculus from another of our videos, but imagining what kind of membrane could reasonably evolve into both of the structures of the flying dragon superorders we have yet to see was a really fun challenge. I hope you guys enjoyed this new video format. If you did, please say so in the comments below, so I know to make more videos of this type with different biological mechanisms or evolutionary tendencies you guys might enjoy seeing on the channel. And remember, if there's any type of creature you'd like me to give the speculative biology treatment in the show, please sound off in the comments below. Thank you all for watching, and see you next time on the Speculative Wildlife Research Center.